And the next question is, a standard hydrogen electrode in contact with a buffer solution of acetate and acetic acid is in the ratio of X is to Y is found to have a potential of E1. So we are given E1 as the potential that is developed when we are taking the electrolytic cell or single electrode acetate acetic acid. It's a buffer solution with some H plus concentration where this is connected to hydrogen electrode and the potential of course is given as E1 with respect to buffer. Which buffer? Acidic buffer where acetic acid and acetate, in fact it's given as acetate ion, that is salt, plus acetic acid, where these two are taken in the ratio of X is to Y, that is 1. And what is the other one? The potential once again developed is E2 for the same acidic buffer, but what is the difference? Now it is acetate ion CH3COO minus and acetic acid. Both are in the ratio of Y is to X. Now what we are asked is, what is pKa? This is what is the question is. Now when this acidic buffer solution which is connected to hydrogen electrode, then the half reaction that takes place in acidic buffer in this single electrode is given by H plus of concentration 1 gains the electron to give half H2. Therefore, the potential E1 is supposed to be, the standard reduction potential for hydrogen electrode is 0. So it is minus 0.059 by only one electron we are involving by 1 into log of hydrogen to the power of 1. So the partial pressure of hydrogen here is 1 atmosphere. Therefore, straight away we can put 1 by H plus of 1 concentration. So this is equation 1. Now this we can rewrite it as E1 is equal to minus 0.059 and log of 1 by H plus is pH. So for 1 concentration, say pH 1. Let us take this as the second equation. Similarly, for the same buffer, when the concentrations are reversed, if the potential is E2, we can write it as minus 0.59 of pH 2. Equation 3. And for the given buffer, that is acetate acetic acid buffer, where they are in the ratio of X is to Y, we have pH 1 is equal to P of Ka plus log of salt concentration X, acid concentration Y. Let us take this as equation 4. Similarly, pH 2 is equal to pKa. For acetic acid is same value, this and this is same, plus but concentration of acetate ion, that salt and acid, are reversed. So therefore I write log of Y by X is equation 5. So that from 4 and 5 we can write as pH1 plus pH2 and P of Ka plus P of Ka is equal to 2 pKa, and this is log X by Y plus log by Y by X get cancelled. So this is, say, equation 6. From where we can write P of Ka is equal to P of H1 plus P of H2 by 2. So this is what indirectly pKa we want. Therefore, from this we can write P of Ka is equal to P of H1. From this equation 2 we will write as minus E1. What will be pH1? Minus E1 by 0.059. So that I am writing here. Plus pH2. That I write it as bringing this minus E2 by 0.059. By as a whole is 2. So here minus E1 minus E2. In other words, we can write 1 by 2, and even why not we can take out the common 0.059 also, into minus E1 plus minus E2. So minus, if I take out the common, this is E1 plus E2. So this is the relation we are getting between pKa and E1 and E2. So E1 plus E2 totally multiplied with negative sign. Now let us observe the options given. The option A given is E1 plus E2 by 2 into 0.059. But we got the negative sign. Therefore, option A is wrong. And when we see the B option, minus of E1 plus of E2 is there. We have got the answer as minus of E1 plus E2. In other words, the negative sign is for both E1 and E2. Therefore, B option is wrong. E1 minus E2 wrong. Then let us check this D option. Minus 1 by 2 into 0.059 into E1 plus E2. So the negative sign is whole for E1 plus E2. In other words, minus E1 minus E2 by 2 into 0.059. So therefore, this is the right option.